So here are more identities that will help you. So in the other video, we did a little bit using the Pythagorean identities and the reciprocal and quotient identities. So those were the most fundamental identities, so the ones that you probably use the most. There's other identities. These are what we call the even and odd identities. So these are just properties of when a function is odd or even, and we kind of talked about it a little bit when we're graphing sine and cosine. We said that the sine curve, sine of x, is basically an odd function, and we also said that the cosine of x is an even function. So that's kind of what we discussed. So and then we also can know about the tangent. So basically these even and odd identities, which is basically these guys right here, it basically says what happens if I put a negative inside of the sine or the cosine or the cosecant and whatever. So notice here what I'm underlining in purple, I'm putting in a negative. So basically if I put a negative angle in here, then what's gonna happen is that this negative can actually come on the outside. And then this guy, so it's basically just the negative of the sine of the angle, okay? If I put a negative in the cosine, it doesn't matter. It's going to be equal to just cosine of theta. Okay. And same thing with the other ones. So the tangent, the only ones that kind of just behave the same are just the cosine and the secant. Notice that if you look at that, if you plug in a negative angle inside, it doesn't really do anything to it, right? It's not affected. It's still going to be positive. The only one and the other ones that are a little bit weird are the sine, the cosecant, the tangent, and the cotangent, or actually the negative of the inside goes on the outside, as you can see. So these are just another additional identities that you can kind of look at, and we'll go ahead and try to verify this identity using this even and odd formulas. So here we want to verify the identity. Okay, so clearly this guy looks more complicated. Okay, so I'm going to start off with the left-hand side. So we're going to have cosine of negative x plus the sine of negative x divided by the cosine of x. So if you look at the cosine of negative x, let's go ahead and take a look at what exactly that equals to. So the cosine of negative x, which is basically this guy, is just equal to the cosine of x. So this guy is just going to be equal to cosine of x. And that's just by using the even and odd identities. Then plus sine of negative x. Well, sine of negative x, that means that the sine now is going to, the negative is going to be on the outside. So it's going to be negative sine of x. Okay, so I'm here. All I'm just doing is using the even and odd identities. So I'm just going to write even and odd identities. Okay. All right. So now in this case, notice that what we can do is that we can just kind of like do the same thing that we did in the previous problem. Divide this cosine to both of these guys. So you're going to have cosine x over cosine x minus sine x over cosine of x. And then you can see that cosine over cosine gives me 1, sine over cosine gives me tangent, which is basically equal to the right-hand side, which is this guy. So that concludes my proof. Okay. Alrighty. So just using the identities, plugging them in, that's basically all there is. So let's try something a little bit more involved. And before we begin that one, there's something that I just kind of want to remind you guys. Remember that whenever you have sine squared of theta, right, or x or whatever you want, right, this is basically the same as sine theta whole quantity squared. Okay. So imagine that so sometimes rewriting it like this might be a little bit easier for you to see. Okay, so clearly here this guy is really complicated. Okay, so we're gonna start again with the left-hand side. So we're gonna have sine squared of negative theta minus cosine squared of negative theta divided by sine of negative theta minus cosine of negative theta. Okay, so I think one of the things that we should do is probably rewrite the squared so that it's on the outside. Okay, so kind of write it as sine of negative theta, the whole thing squared, minus cosine of negative theta, the whole thing squared. So kind of write it like how I kind of just said it here. Okay, because that's basically equivalent. I'm not using any identity. This is just basically how we write the sine and the cosine. Okay, on the bottom part, we can kind of use an even and odd identity. So we know that this guy is going to be equal to negative sine of theta. And then this guy, we have a minus on the outside. And then this guy is just going to be cosine of theta. Okay. All right, so now on the top part, we can now use the even and odd identities again. This guy is going to be negative sine of theta. There's a square there. And this guy right here is going to be positive cosine of theta. And we know that there's a square there. Divided by, here what I can do, I can factor out a negative, sure. Negative, and then you have a sine theta, and then you have a cosine theta. Okay, and now here, notice that this negative is going to get squared. That's going to give me a positive, and it's going to be sine squared theta. And then this guy is going to be minus cosine squared theta. Divided by, I have a negative sine theta plus cosine theta. Okay. Now what I can do on the top part is that I can factor this. So the top part right here, I can factor it as sine theta minus cosine theta, and then sine theta plus cosine theta. Okay, divided by negative sine theta plus cosine theta. Okay, so this one, basically, if you remember from algebra, this guy is basically a squared minus b squared. So it's basically here the sine is a squared, the cosine is b squared. So whenever you have two different things that are being squared, the factored form is a plus b, a minus b, or you can write a minus b, a plus b. So that's kind of how I did it here. That's how you got the a plus b, a minus b. So just in case you forgot this algebra tool, I'll leave it there. So now you can see that this guy is going to cancel out with that guy. So all we're left with this negative there. And then you just have a sine theta minus cosine theta. You can distribute this negative now. So I have negative sine theta plus cosine theta. I can just switch it around and write cosine theta first, which is a positive, and then the negative minus sine theta. And this is basically now my right-hand side, which basically means that I am now done with this guy. Okay, so a lot more involved, a lot more factoring, right? But still using the same identities, being able to tap into our algebra toolkit, and just be able to cancel things out, factor, and using identities.